neutral axis, right? And then you can see that in your element K, right, for your element K is going to be in the compression. Okay. Then you see over here, anything else to analyze? The answer is no. Now the interesting thing is this. You ask me, Eugene, when is the moment taken, or when do we take the moment to the element, and when do we take the moment to the neutral axis, right? The one before, right, we take the moment to the what? Neutral axis. I'm talking about this one. We're talking about, right? Right. Well, for this case, right, we're not taking towards the neutral axis, but we are taking towards the what? The element, right? So when is it towards the element and when towards the neutral? So towards the element, so when the perpendicular distance, or when the perpendicular distance is parallel to the neutral axis, right? To the neutral axis. So when I mean parallel, this is what I mean parallel, right? So all these are parallel to the neutral axis. Okay. Then the moment is taken at the element location. Okay. So if the perpendicular distance is parallel to the what? Neutral axis, like what you can see down here, like what's highlighted down here. Then you take the distance to the what? To the element. Okay. Now, after seeing this, anything else to analyze? If you look further, nothing else to analyze, move on. Okay. So we have to do our last view now. Okay. So the last view that we're going to do, all right, the final view we're going to do is we're going to look at the front view now. Okay. We're going to look at the front view. So when we look at our front view, we have our so now wait before so what do I mean by front view? So this is our Y, this is our Z, okay, and then this is our rotation in the X. Okay, so this is what we see in the front. You have something round like that, and then you have this is just a sketch. Okay, okay, now we have all this. Okay, so when now we're going to draw our forces. So you have your 200 pounds over here, right? And then you have a dot coming out. This is your 150, right? And then you have your two forces over here is the 150 pounds, and you also have your 50 pounds. So if you look at the 150 pounds, the 150, I mean, all the load we have analyzed before, but there's one we have not. Okay, and this is the one that is doing this. So we have this distance over here. Okay, wait. We have this distance from here to. We have analyzed it before, but we have to analyze it again, and I'm going to explain to you why. Okay, so if we look at this distance over here, all right. All right, so we have a perpendicular distance over here. Next, I'm going to draw our neutral axis. So now our neutral axis is a dot. Right? So that is our neutral axis. I'll draw it the other way. Right? That's our neutral axis. And then this is our element. Our element H. And over here, this is our element K. Right? So if the 200 is going to push, right? The deformation now will look like this. Okay, if the 200 is going to push. So when we push the 200, you have this sort of deformation. Okay, yeah. So this is your 200. Right? And this is your deformation pattern. Okay. Now, when you look at your neutral axis, what happened to your neutral axis? Did your neutral axis deform? Can anyone answer me? Did your neutral axis deform? Is it a banana, or is it a smiling face or a sad face? Okay, so if it's not a smiling face or a sad face, it's at the same position, then it's equal. Then the applied load is inducing a what? A torque, right? So let's look at. I'll write what I said again. Okay, I'll write this out. So torque, right, is equal to force multiplied by radius, right? And when is it a torque? Okay, so when the neutral axis, okay, when the neutral axis remains in the same exact location during deformation, right? So when after deform, like what I drawn in orange, right? The deformation pattern, the structure deform, it rotates, yes or no, right? Then the neutral axis, the green dot is still the same. Then the loading, the load, right, is inducing a torque. Okay. If you look at the other situation over here, like this one, right? The neutral axis is bending in that direction, right? That is a what? A moment. Then the one before, right? So the one before the neutral axis, I'm going to draw this, is going to bend in this direction. It's going to bend in this direction. Right? It's bending in that direction. So this is the deformation, right? Then it is also a moment. Whereas for this case, relative to the what? to the neutral axis, when 200 pounds is applied, it is not deforming a smiling face or a sad face, but it's at that point. Okay, just looking at the 200 pounds. So when that's the case, it's going to be a torque. So you write down here, torque, all right, torque in the x direction, right, is equal to 200 multiplied by 10. So this is equal to 2,000 pound-inch, and it's going to rotate in this direction. Okay, so this is where it's critical. You need to be able to identify when is it a moment, when is it a torque, right? When is it an axial load, and when is it a shearing force? Okay, so just to quickly recap, right? So when is it a bending moment, right? When is it a bending moment? Like what I highlight is when what? I'll highlight again, okay? So when the neutral axis deform pattern is either a smiling face or sad face, then the force induced is inducing a moment. And the moment, right, if for this case, right, is not relative to the element, but to the what? Perpendicular distance. Okay, so if the perpendicular distance is perpendicular to the neutral axis, you use the perpendicular distance. That's one thing that we learn. And then we learn also what? When the applied force is along the neutral axis, then it's under the what? Axial loading consideration. Okay, and then we again learn in terms of torque. Okay, so again, an important thing, when the neutral axis remains the same exact location during deformation, then the load is inducing a torque. So this is how you identify whether it is a moment, a torque, and then the shear force, right, is always acting what? Perpendicular to the neutral axis. So all these are all your what? Shear forces. Okay. So what I propose, we go for a 15 minutes break. Okay. Then we come back. So we come back at about 8:45. Dajinder, I think I've uploaded them on the Avenue to Learn. Did I not, Dajinder?
I couldn't find it. Maybe you did, but I just couldn't find it.
Wait. Don't go anywhere.